Hello, my good friends. My name is Tete Jacob Sirichi. Welcome to my YouTube channel. Today, we are still on the finding root of complex polynomial functions. And we said that when we are asked to find at least one root for complex polynomial function, a lot of methods are used. We have the bisection method, method of successive approximation, the the false position method, the Newton iteration method, Horner'S method, the scanty method, among others. Please check out my videos on how to find at least one root for complex polynomial function using all other methods. Today, our attention will be on the Horner'S method. So, before the video ends, I will take you through what the Horner'S method means. Then, how to solve some sample problems using the Horner'S method. This will be a very interesting engagement, I promise you. So watch the video till the end. So the Horner'S method was discovered by a man known as William George Horner. And what did he say? He said that if f of x is a polynomial function and a root exists within the interval a, b, where b is greater than a, then at least a root of the polynomial function f of x is equal to a point d1, d2, d3 in that order. What is that d1, d2, d3? The d1 and the d2, d3 are gotten from the interval, the subsequent interval we get from our transform and new equations. How do we find that transform and new equations? We take some sample equations and see how we put that into practice. So our first example says that we should use Horner'S method to solve x cubed plus 9x squared minus 8 equal to 0, correct to two decimal places. So how do we do that? Please, with the Horner'S method, the location theory will also play a very important role again. The location theory, if you realize, play a very important role in finding the root using all other methods. So we need to use the location theory again. So let our f of x be equal to x cubed plus 9x squared minus 80. So we'll find f of 1. When you find f of 1, you get negative 8. When you find f of 2, you get 26. That means the root exists within the interval 1, 2, close. I hope you get that. Then our proposed root, the root will be equal to, remember this is a, so it will be 1 point d1, d2. Since they say correct to two decimal places. How do we get our d1, d2? So our d1, d2 is getting from the diminution of our transform and new equation using the interval that exists within that, or that exists within that equation. So how do we get that? We need to diminish this function using the 1. So we are just going to use a table to do that. So our table will look like this, where we write the coefficients of our function down. So the coefficient here is 1, the coefficient there is 9, the coefficient of the x term will be 0, and the constant term is negative 18. Then we use the 1 to divide. This is how we go. So we let 0 come here, add 1 to 0, or we draw a line and write 1. Since there is nothing here, we say it's 0. 1 will multiply this 1 is 1. We write it here. 9 plus 1 will give us 10. 1 will multiply this 10, we'll get 10. 0 plus 10 will give us 10. 1 will multiply this 10, we'll still get 10. Negative 18 plus the 10 will be minus 8. Then we are done with this 10. Then we find the next. So 1 plus nothing, so it will be 1. We put 0 here. 1 times this 1 will give us 1. We write it here. 1 times 10 will be 11. 10 plus 1 will be 11. 1 times 11 will be 11. 10 plus 11 will give us 21. Then we are done with this as well. We come here again. 1 plus nothing will give us 1. That's 0. 1 times the 1 will be 1. 11 plus 1, that will give us 12. Then we are done. So our transformed equation will be our transform function equation will be equal to, the coefficient here is x, so s1, so x cubed plus 12x squared, then plus 21x, then minus 8. That's our transform equation. How do we get a new equation? The new equation is gotten by multiplying this 10 by 10 exponent 0, this by 10 exponent 1, this by 10 exponent 2, then this by 10 exponent 3. Remember 10 exponent 0 is 1, then 10 exponent 1 is still 10, so we'll multiply this by 10. 10 exponent 2 is 100, so we'll multiply 21 by 100. 10 exponent 3 is 1000, we multiply 8 by 1000. So our new equation will be x cubed plus 120x squared plus 2100x, then minus 8000. So that's it. We need to find this our d1. How do we get this d1? We'll get d1 from the location theory. So remember our f of x will now be x cubed plus 120x squared plus 2100x minus 8000. On find f of 3, we'll get negative 593. And when we find f of 4, we'll get 2884. So we can say a root lies within the interval 3, 4 close. So our d1 is now 3. So we can say that our root now we have 1.3 d2. We need to find that d2 again. Remember they say to 2 decimal place. We need to find the d2 again by doing the algorithm, the division algorithm for our new equation. So we'll still draw our table. Then we write the coefficients 1, 120, 2100, then minus 8000. So what we use to divide? We use the 3 to do that. So 1 plus nothing, so that will be 1. So we say 1, we write our 0 there. 3 times this one will give us 3. 120 plus 3 will be 123. Then 3 times 123 will be, so 3 times 123 will give us 369. 369. When we add 369 to 2100, we'll get 2469. Then 3 will multiply 2469 again, we'll get 7407. When we add 7407 to negative 8000, we'll get minus 593. So we are done with this. Now we come to the next. Remember 1 plus nothing will be 1, that's 0. 3 times 1 will be 3. 123 plus 3 will give us 126. 3 times 126 will be 378. When we add 378 to 2469, we get 2847. Then we are done with this. Then we come to the next. 1 plus nothing will be 1, that's 0. 3 times 1 will be 3. 3 plus 126, that will be 129. Then we can get our transform equation as x cubed plus 129x squared plus 2847x, then minus 593. So having gotten our transform equation, we need to find the new equation. And how do we get the new equation? The new equation will be gotten by multiplying this by 10 exponent 0, 10 exponent 1, 10 exponent 2, 10 exponent 3. Remember, 10 exponent 1 will still be 1, so 10 exponent 0 will still be 1, so we have s exponent 3 for that. Then this 10 exponent 2, 10 exponent 1, 2 will be 100, so we have plus 10 exponent 1 will be 100, so 1, 2, 9. 10 exponent 1 will be 10, times that will just be adding 10 to that. Exponent 2, this will be times 100, so we have 284,700 x. Then this times 1000, we have 593, 1, 2, 3. I hope you get that. Now, this becomes our f of s. So our f of s is equal to s cubed plus 1290 s squared plus 284,700 minus 593,000. I hope you get that. So now we need to use the location theory again to get the interval. So I want to find f of 2. That's substituting 2 into this function. We'll get negative 18422. Then we want to find f of 3. We'll get 272737. Please, this is 32. Negative 18432. I hope you get that. Then we can say that a root exists within the interval 2, 3, using the location theory. Now we diminish what? Our f of x by 2. Then we can say our d2 is equal to 2. So, having gotten this 1.3 d2, our d2 is now 2. We just substitute it. So now we have 1.32 as one of the root for our polynomial function. Then we can say if we have s cubed plus 9s squared minus 8 equal to 0, then one value of x is equal to 1.32. I hope you get that. This is all about the Horner's method. So if they say to 3 decimal places, then we have to do the division algorithm again using the 2 in that order. I hope you get it. You solve one more example where we have 3 decimal places so that you'll be abreast with the concept. So solve our second last example, that's to 3 decimal places. So this will be a little bit lengthy. So remember to subscribe to my YouTube channel if you are here to like and comment. This will make my YouTube channel grow more and I can record more mathematical content for you. Can we have a deal? Okay, so subscribe, share, comment, and I will record more mathematical content for you. Now, they say use Horner's method to find at least one root of the polynomial x cubed minus 3x plus 1 equal to 0, correct to 3 decimal places. So how do we do this? So we can say our f of x is equal to x cubed minus 3x plus 1. Now we need to use the location theory to find the interval where the root exists. So we find f of 1. If you find f of 1, you get negative 1. And when you find f of 2, you get 3. Then we can say roots exist within the interval 1, 2. I hope you get that. So we can say that root, the root is 1.d1, d2, d3, since they say 3 decimal places. I hope you get that. How do we get our d1, d2, d3? So we diminish x cubed, that's our function f of x, by 1. How do we diminish? We just use a table to do that. We'll write the coefficients here. So we have 1. Remember, the coefficient of the square term is 0. The coefficient here will be negative 3, then 1. We are going to diminish by 1. We'll draw our line. So 1 plus nothing is 1. That's 1 plus 0. 1 times 1 will be 1. 0 plus 1 will be 1. 1 times 1 is 1. Negative 3 plus 1 will be negative 2. 1 times negative 2 will be negative 2. 1 plus negative 2, that will be negative 1. Then we are done with that one. We have the next. So 1 plus nothing is 1. That's 0. 1 will go into, 1 times 1 will be 1. We write it under that. 1 plus 1 will be 2. 1 times 2, that will be 2. Negative 2 plus 2, that's 0. We are done with the other one. Then we come here. 1 plus nothing is still 1. That's 0. 1 times this one will be 1. 2 plus 1, that will be 3. Then we are done with that. So our new equation now will be x cubed plus 3x. We can set x cubed plus 3x squared, then plus 0x if we wish, then minus 1. So having gotten our transform equation, we find a new equation. So our new equation, remember, we'll be multiplying this by 10 exponent 0. So that will be 1 times that will be this. This by 10 exponent 1, that will be 10. So plus 30x squared. Since this is 0, all multiply anything by it, it will be 0. Then this by 10 exponent 3, that will be 1000. I hope you get that. Now, you can say our f of x is equal to x cubed plus 30x squared minus 1000. What do we need to do? We need to use the location theory to find the interval. So we find our f of 5. When you find f of 5, you get negative 125. Then f of 6 will be equal to 296. That means a root exists within the interval 5, 6, close. So we can say our D1, our first decimal place, is 5. Then we can replace it here. So we'll get 1.5 D2, D3. So our root now, the root is 1.5 D2, D3. We need to find a second decimal place, then a third decimal place. So now we'll diminish this equation again by 5. So we'll diminish f of x by. So how do we diminish? We just form a table and we'll do that. So our table will be like this. We write the coefficients 1, 30. Since the s term is not there, is 0. Then we have negative 1000. So by 5. 1 plus nothing will be 1. So we have 1 there. 5 times 1 will be 5. 30 plus 5, that will be 35. I hope you are getting it. 5 times 35 will be 175. Then 0 plus 175 will be the same 175. I hope you are getting that. 5 times 175, that will give us 875. Then minus 1000 plus 875 will be negative 125. I hope you get that. So we are done with this. Now we come to the next line. 1 plus 90 is still 1, that's 0. 5 times 1 will be 5. 35 plus 5 will give us 40. 5 times 40 will be 200. 175 plus 200 will be 375. Then we are done with this. The next one, 1 plus 90 is still 1, that's 0. 5. 5 times this one will give us 5. 40 plus 5 will be 45. So our transform equation will be x cubed plus 45x squared plus 375x minus 125. So having formed our transform equation, we can form the new equation. So our new equation will be multiplying this by 1, this by 10, this by 100, and that by 1000. So it will be x cubed plus 450 x squared plus 37500x, then minus 125000. Then we can say our f of x is equal to x cubed plus 450 x squared plus 37500x, then minus 125000. So now we find f of 3. If you find f of 3 by substituting 3 here, you get negative 8425. And when you find f of 4 will give you 32264. That means a root exists within the interval 3, 4, close. So automatically I will know that our D2 is 3. So remember, we're having 1.5 D2 D3. So we will replace the D2 now by 3. So now we have 1.53 D3. So we need to find a great 3 again. So we diminish our f of x by 3. So how do we diminish? So we use the table again. We write the coefficient of our transform equation. That's 1, 450, 37500, then negative 125000. So what do we do? We use the 3 to diminish that, so 3. Then 1 plus nothing is 1, that's 0. 3 times 1 will be 3. 450 plus 3 will be 453. 3 times 453 will be 38859. So 3 times 453 will give me 1359. When we add 1359 to 37,500, we get 38,859. 3 times 38,859 will give me 116577. So we add 116577 to negative 125,000. We'll get negative 8423. Then we are done with that. Now we come here again. 3. 1 plus nothing will be 1, that's 0. 3 times 1 will give us 3. 453 plus 3 will be 456. 3 times 456 will give me 1,368. I hope you get that. When I add 1,368 to 38,853, I'll get 40,227. So we are done with this again. We do the last one. So 1 plus nothing again is 1. That's 0. 3 times 1 will be 3. Then 4, 5, 6 plus 9 will be 4, 5, 9. Then we are done. So our transform equation will be 1x cubed plus 459x squared plus 40,227x, then minus 8423. So, how we form our transform equation, we'll find a new equation. So our new equation, remember, is by multiplying this by 10 exponent 0, and that's 1. So we'll still have x exponent 3. Then multiplying this by 10 exponent 1. So that will be 10. So we have plus 4590 x squared. This by 100. So we get plus 4022700 x. Then minus this by 1000. So we get 842312 zeros. You can say our f of x now is x squared plus 4590 x squared plus 4022700 x, then minus 842300. Now we need to use the location theory to find the interval again. So we find f of 2. If we find f of 2 will give us negative 3 million, and our f of 3 will give us 3,600,000. I hope you get that. So we can say that a root exists from location theory using within the interval 2, 3. So our D3 now is 2. So we can say, remember we have 1.53 D3. So this is D3. We just substitute there. So one root for the polynomial x squared minus 3x plus 1 is 1.532. Correct to 3 decimal places. I hope you get that. This is all about the Horner'S method. Very, very interesting. You practice more, you become used to it. We'll end it here today. Before you sign, remember to subscribe to my YouTube channel. This will make my YouTube channel grow more, and I will record more mathematical content for you. Until we meet again, my name is Kepsi.